Chapter 9, Stress Transformation, Mohr Circle. Example 1. So in this example, we want to calculate the principal stresses and also maximum shear stress for the below elements. So it just says we want to calculate principal stresses is goes by sigma max and also sigma min, and maximum shear is just tau max. Let's see how can we approach this problem with Mohr circle. So if you look at this side, which has a normal of 50 megapascal, and that plane, the normal of that plane is in, that's x, this is y. So the normal, the plane which its normal goes by x is the plane of x, and there is a 40 megapascal a friction or shear stress on the plane of x. And if you remember, if a shearing stress is tends to rotate the elements in a counterclockwise, the points in Mohr circle goes below x-axis. So that says if we want to plot, for example, point x, it goes below the x-axis. And at the same time, if you look at the y element, which has a 10 megapascal, a compressive stress, and a 40 shear. And if you look at that part, it just the 40 megapascal tends to rotate the element in a clockwise condition. So that points comes to about the x-axis. So this is x-axis. So let's see how that goes. So if you want to project those two planes by 2 points in Mohr circle, x it goes by a 50 megapascal tensile stress and a negative 40, which the counterclockwise rotation brings us to the a negative or below x-axis. That's a negative 40. And if you look at the other element, it's a 10 uh, compressive 10 megapascal compressive stress, that's a negative 10, and a it tends to rotate the element clockwise, so that's a the point goes the at it above the x-axis, and that's a positive 40. Mhm. If we draw the a circle based off these 2 points, and then we want to know what are the principal stresses, that's sigma max and that's sigma mean. Let's see how we can solve that. Sigma average is sigma x plus sigma y over 2. So if we know this is sigma x, from our origin, this is sigma x, and this is our sigma y. If you add them together and divide it by 2, it just gives you the sigma average, which is the center of our circle. Mhm. And that's a positive 50 plus a negative 10 over 2, and that's a 20 megapascal. And one can simply say sigma minimum on a Mohr circle is here, and this is sigma max. And sigma max is simply sigma average, which is the center, plus if you add a radius to that, you get to get it gets you to sigma maximum. And if you subtract sigma average this time minus r, it gives you to sigma minimum. So principals or principal stresses, it just simply if you calculate sigma average, which is the center of our circle, and add that with a radius, it gives you to sigma max. Uh-huh. And if you subtract that from an R, it just gives you sigma mean. As soon as you have sigma average, you can calculate a sigma max or minimum. And at the same time, let's see how we can calculate sigma R as R, which is the radius itself. So we already have the sigma average. Now we just need to know how to calculate the numeric value of R, and for that part, if you want to know how to calculate R, it just gives you, if you call this point F, uh-huh, and one can simply say sigma in this triangle, R or hypotenuse is xf squared plus cf squared. So xf squared is just a negative 40. So that's a tau xy squared. So that's 40 squared. Uh-huh. But cf is just sigma x minus sigma y, uh-huh, divided by 2. So it just gives you the numeric value from C to F. That's a CF is just sigma x minus sigma y over 2. So how that goes from C to F is just sigma x minus sigma y over 2. And if you have CF and you have XF, you can easily calculate the radius. So that's a sigma x minus sigma y over 2 squared plus tau xy, which is 40 squared, the square root of that. So that's a 50 minus a negative 10 over 2 squared plus 40 squared, or negative 40 in parentheses square, and that gives you a numeric value of R 50 megapascal. Mhm. So if you just replace that in the formula of sigma max and sigma mean, it just says if you add sigma average, which you already calculate that, which is 20 megapascal, with the radius, which you calculate that to be 50, and a negative R, it just simply gives you the numeric value for sigma max, which is 70 megapascal, and sigma minimum, which is a negative 30 megapascal. And if you want to know the tangent of 2 theta p, if you call this angle 2 theta p, which is a theta of principal, if this is sigma max, and this is our original plane. So by an angle of 2 theta p, it just get us to sigma max. So tangent of 2 theta p, it's a CF, which is CF is sigma x minus sigma y over 2. So tangent of this angle, tangent of 2 theta p, it's equal to sigma x, which is CF minus sigma y over 2 over, my bad, that's a tau xy over that tau xy over sigma x minus sigma y over 2. So it just says tangent of this angle is tangent of 2 theta p, it just rise over run. My rise is tau xy, my run is a CF distance. That's sigma x minus sigma y over 2. If you just replace that 2 at the top, at the numerator, it just gives you 2 tangent of 2 theta p. It's equal to 2 tau xy over sigma x minus sigma y. So if you do the math, that's a xf over cf. That's xf, that's xf that's xf over cf. And that's a 40 over cf, which is 30. Mhm. Cf is just sigma x minus sigma y over 2. And or sigma x minus sigma y, or just cf. If you do the math, it just gives you 2 theta p is 53.1 degrees, and hence theta p is 26.6 degrees. The angle which gives you from the original plate to a sigma maximum, which has that's a plane with no shear. Mhm. And at the same time, if you want to calculate the maximum shear, since if you look at the Mohr circle, this is the original plane of X with 50 normal and negative 40 shear. And by 2 theta p, it just gives you to point A, which is sigma maximum. And the plane for that goes by the plane of sigma maximum. And by a rotation of another 90 degrees, it just gives you to the maximum shear. How is that? From the Mohr circle, this is a sigma direction. So this is sigma, sigma, and this is tau. So you can simply see that the maximum sigma, maximum or minimum happen at x axis, and the maximum shear, it happens at the both ends. So that's a maximum shear. And if you look at the Mohr circle, the maximum shear is simply the numeric value of r. That's a radius of our circle. So since a further 90 degrees counterclockwise rotation brings CA to CD, which is the maximum shear. That's tau max is equal to radius, and that's the radius is, we just calculate in previous step that the radius is 50 megapascal. And just in case in Mohr, whatever you have in Mohr circle, mhm, it 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 so in Mohr circle 2 theta p plus 90 degrees, and if you want to translate it in a 2D plane, that goes by half. That's a theta p plus 45. Mhm. So it means if you remember our original sample, by a theta p of 26.6 degree from x goes to sigma maximum of 70 megapascal, which has no shear and just sigma mean and sigma max, just by a rotation of 26.6, which is a theta p, and with a further rotation with a further theta p plus 45 degrees, it just gets you to the maximum shear. So that's the plane of maximum shear, and that's equal to r, and that's equal to sigma maximum. And that's tau max. And definitely you do have a sigma prime on that. You do have a sigma prime on that, but in a principal plane or maximum normal, you just have a minimum and maximum normal stress, no shear. That's the the concept of principal stresses. And let's see how that 20 comes sigma prime in maximum shear. So if you look at the previous slide, it just simply showed you that the let's go here. You can easily see that. So even before that, so sigma average, which is average is from origin, average is from origin to center. And if the plane of shear is here with tau, that's a tau maximum, and that has a tau maximum equal to R, which is 50 megapascal. And you can easily see sigma x for that plane, sigma x for that plane is just simply a sigma average from O to C. That's from O to C, which is sigma average, and that's 20 megapascal. That that is how these 20 and 50 comes in the plane of uh, shear maximum shear, which has a 50 megapascal and in shear and 20 megapascal in normal stress. Thank you. We'll review more example in next videos. Thank you.